Okay, here we go. I'm going to talk about how to solve the S12C Part 2 normals. But first we're going to talk about finding an equation of a curve using the calculator given 3 points. So 2, 0, -4, 0, and 0, 12 are these 3 points right here. So we simply follow these steps. So here's my calculator. I'm going to hit stat, and then I'm going to hit enter because I want to edit. So hit enter, and I want to clear this stuff. I can go to the top and hit clear and enter. I'm going over here, clear and enter. Let's start with some fresh columns. And so now I'm going to put 2, -4, and 0. 2, -4, and 0. And then over here, I'm going to put 0, 0, and -12. Okay, those are the 3 points, 2, 0, -4, 0, and 0, -12. Okay, now I follow these other steps. I hit stat. I'm going to arrow to the right until it says calc. And then I'm going to go down to number 5 where it says quad reg, and then hit enter. And L1, L2, I'm going to go down here, calculate, hit enter, and now it tells me A, B, and C. So basically what they've said is our equation is y equals 1.5 x squared and 3x, ignore that, and -12. Okay, so you do that same steps for all of these, and you will get these answers. Okay, so the points I used here is -2, 2, -1, 1, 0, -2. Okay, so you may want to hit pause and to copy this down. Okay, so now that we're ready to move on, so we're going to talk about what is a normal. So a normal, the definition of a normal is a perpendicular line to the tangent line. So this line that I've drawn here in green is called our tangent line, and the tangent line touches the curve at one spot, right? The tangent line touches the curve at one point. And it also does not go through the point. Does not go through. What I mean by that, you don't have a curve and it doesn't like go through. That's not a tangent. Okay. So it touches it at one point and it doesn't cut into the thing. So the normal is a perpendicular line to this. Okay, so when we are dealing with our normal, whatever the slope is for our the tangent line, the perpendicular is the reciprocal, and we change the sign. Okay, so the normal slope has an opposite sign and the reciprocal of the tangent. So you probably want to write this down. So what is the normal to a curve? It's a perpendicular slope to the point of tangent. Okay, you might want to hit pause and copy that down. Okay, so I'm going to do this first one with you guys, or first few with you guys. Okay, so Find the equation of the normal to the curve at the point where x equals 1. Okay, so the first thing we got to do is I need to plug in 1 into my original equation. 2 times 1 cubed plus 3 times 1 minus 2. Okay, because we don't know the y value. We want to find it when x equals 1. So if I plug in 1 into my original equation, I'm going to get 2 plus 3 minus 2. So f of 1 is going to be equal to 3. Okay, so that means the point we're working with is 1 comma 3. Okay, all right. So now we need to find the slope. So first thing I do is I find the derivative. So the derivative of this, it's 2x cubed, so it's going to be equal to 6x squared. And the derivative of 3x is just plus 3. And the derivative of negative 2 is 0, so that goes away. So here's my derivative. And now I'm going to plug in 1. So, and we get 6 times 1 squared plus 3. So that's going to give me 6 plus 3, which is 9. So my slope at the point of tangency there is 9. So that means my perpendicular slope, I'm going to represent perpendicular with this upside down t. So that means the perpendicular slope is going to be negative 1 over 9. So using this and the point, I'm going to be able to find my new equation. So, okay. So what I'm going to do now is we got y minus y1 equals mx minus x1. Okay, so this is the equation of a regular line. So I'm going to do y minus, the y value is 3. My new slope is negative 1/9. X minus, and my x value is 1. Okay, so now I can do distributive property with the 1/9, and I got y minus 3 equals negative 1/9 x plus 1/9. And now I can add 3 on both sides, and I get y equals negative 1/9 x plus 3 and 1/9. You might want to hit pause or rewind to see this again. Okay. Yeah, let's just set this up there. Okay. So the slope of the normal curve at point 1 comma b is that. Okay, so first let's find the derivative. So the derivative of this is going to be 3k times x squared minus 2. That's the derivative of this function. Okay, so if my perpendicular slope is negative 1/4, then that means my regular slope is going to be equal to positive 4. Now, why do I need the regular slope? Because I'm going to plug 4 into the slope of this is 4, and I need to substitute that in order to find k. Okay, we have to find k first before we can find the value of b. Okay, so let's rewrite. I'm going to replace this here with 4. So now I've got 4 equals 3k x squared minus 2. And I really should have plugged in a 1 for x, because this is when x equals 1, right? Right. So We have 4 equals 3k times 1 squared minus 2. So I've got, let's add 2 on both sides. And then I've got 6 equals 3k. And I can divide both sides by 3. And then I get k equals 2. Okay. Now I can go back to my original function. And we want to find b. So b is the y value. So I'm going to replace this here with b. So then I've got b equals k. Oh, we already know k is 2. Right? And we already know x is 1. So 2 times 1 cubed minus 2 times 1 plus 1. Okay, so b is equal to 2 minus 2 plus 1. So that means b is equal to 1. Okay, hit pause if you need to. So let me just show the answers and walk through. Let's just do one at a time. Okay, so find the equation of the normal at this point. So the first thing I do is I take the derivative. The derivative of yx squared is 2x, and then I'm going to plug in 3 in place of x, and so then I know my slope is 6. So my normal perpendicular slope is going to be negative 1/6, and now I'm going to use my equation of a line. I'm going to replace m with negative 1/6. I'm going to replace y1 with 9, and I'm going to replace x1 with 3. Okay, then I can do distributive property with the 1/6 like I did here, and then I add 9 on both sides. Okay. Number 2, I'm going to rewrite it because it was really messy on my first thing. So the derivative of this is equal to 3x squared minus 5. So I'm going to plug in negative 2, and I've got 3 times negative 2 squared minus 5, which is going to give me negative 2 times negative 2 is 4, and 4 times 3 is 12 minus 5. So my derivative is equal to 7. Okay, so my perpendicular slope is going to be equal to the opposite sign and the reciprocal, so 1 over 7. So I'm going to use that. Okay, now I need to get a point. So when x is negative 2, so y equals, I'm taking the original equation, negative 2 cubed minus 5 times negative 2 plus 2. Okay, so that's going to get me y equals negative 8 plus 10 plus 2. And then that's going to get me positive 4. Okay, so now I know my point is negative 2 for x and 4 for y. Okay, so I'm going to use those two things to help me get my equation. So it's y minus y1 equals m times x minus x1. Okay, and let's replace y1 with 4. Let's replace the slope with negative 1/7. Let's replace the x with negative 2. Okay, So y minus 4 equals negative 1 over 7x, and minus 2 over 7. Okay, the final step is I add 4 on both sides, and then I end up with y equals negative 1/7 x plus 3 5/7. Okay, so I'm going to show the next two, and you could just hit pause and you can check your work. Okay, feel free to hit pause. Okay, let's do the next group. Consider this equation. So the thing I like to do first is rewrite this so that I don't have x in the denominator. So I've got y equals 2 times x to the negative 1. Okay, so find the equation, find the tangent equation for this. So the first thing I'm going to need to do is to find the tangent, I need to find the derivative. So the derivative is equal to negative 1 times 2 gives me negative 2, and x, and then this power decreases by 1, so now it's going to be the negative 2 power. Okay, and so at point P, x is 2, so I'm going to plug in 2 in that place. So y equals negative 2, 2 squared. Okay, so what did I just do? I took this value there, the x value, and I plugged it in there. Okay, and then this simplifies to my derivative simplifies to negative 1/2. Okay, so now to find the tangent line, I've got y minus y1 equals mx minus x1. Okay, so my slope is negative 1/2. Okay, y1 is 1 here, right? Slope is negative 1/2 x minus, and my x value is 2. Okay, so now I did distributive property with that negative 1/2, y minus 1 equals negative 1/2 x and plus 1, because 1/2 times 2 gives me 1. Okay, and negative times negative gives me positive 1. Okay, and the final step is I add 1 on both sides, and plus 1, plus 1, and I get y equals negative 1/2 x plus 2. I'm sorry I did not put more space there to solve this. Okay, now the normal, same process, except I'm going to take the perpendicular slope, which is equal to 2. Changes the sign to positive, and the reciprocal of 1/2 is 2. So I'm going to use that. So y minus y1 equals m x minus x1. Okay, so now I'm going to do y minus 1 equals 2 times x minus 2. Okay, I plugged in the 1 and the 2 from over here, and now I can do distributive property, y minus 1 equals 2x minus 4, and then I add 1 on both sides, and my final equation is y equals 2x minus 3. Okay, sketch the tangent and the normal. Okay, so the tangent is going to go through that point, and that's what it's going to look like. Okay, now to sketch the normal, it's just going to cut through there at a perpendicular. Okay. So, same process. I'm just going to show my work from earlier. Pause to copy this down. Okay. Okay, I'm just going to walk through this because things to do. So, okay, we've got these 2 points. So we know it crosses the axis here at +1 and +4. Okay, so the axis intercepts are 1 and 4. Okay, find the derivative. So it's easiest to find this derivative by FOILing this out. So x times x gives me x squared, x times -4, -1 times x, and -1 times 4. So my equation FOILs out to be this. So the derivative of this is right here. And now find the equation of the normal. So first thing I do at x equals -1, so first thing I do is I plug in -1 into my function and I get 10. So now I've got my point at -1, 10. Now I need to figure out the slope. So I plug in -1 in here and I get a slope of -7. That means my perpendicular slope is +1/7. And then I just substitute that in for m. I substitute the -1 and the 10 in for the y, and here's my answer for the normal. This line here in red. Okay, so okay, so the point where the normal at this meets the curve again. So what did we do here? So hint, after you find the equation of the normal, use technology to find the intersection of the graph of the normal line. So, okay, first I found the derivative. So the derivative of y equals x squared minus 3 is this. And so I plug in 1 in here, and my derivative is 2. So if the derivative is 2, that means my normal slope is -1/2. Okay, so now I'm going to plug in -1/2 in for the normal. My point is 1, -2, so I'm going to plug in the 1 and the -2 here. Okay, and then I can do distributive property with that -1/2, and then I subtract 2 on both sides, and here is my equation of the normal. Okay, so the normal line I have highlighted in red, so this is my normal line. Okay. And earlier I said, oh, look, it's supposed to be perpendicular, right? So because of the scale of each of these squares is rectangular, that's why it kind of looks kind of funny. Okay. So now I've got this equation, and I've got my original equation, and we want to find out when this line cuts right here. Okay. So so on my calculator, I'm going to type in the original equation, x squared minus 3, and then I'm going to type in my new normal equation and follow through these steps. So let's do that. Okay. Y equals, and I'm going to type in x squared minus 3, x squared minus 3. And then the other equation is -0.5 x minus 1.5. Okay, and then I graph. Ooh, I need to change my window. I'm going to hit zoom 6. Oops, let's try that again. Zoom 6 to get my standard window. Okay, so I'm trying to figure out, I want to find this point right here, which is right over here. Okay, see where my pen is pointing? So I'm going to press graph to see the picture, which we just did, and second graph to, if I wanted to see, if I hit second graph, I can plot some points here. So having these points would help me draw the line. Okay, so now I'm going to hit second trace, and then go down to 5 where it says intersect, enter. Now if I want to see this intersection where my pen is pointing, I have to arrow close to it. Okay, I'm pretty close to it. So it says first curve, I'm going to hit enter. Second curve, I'm going to hit enter. Yes, I'm going to hit enter. And that intersection is negative 1.5 and negative 7.5. Okay, so I'm going to leave this here for a second. Hit pause if you want to copy this down. Okay, last page. Same question. So I found the derivative to get me the slope, and we want to find out where the normal hits the curve again. So I just drew the curve here, y equals x squared. So that's pretty easy to draw. When x is 1, y is 1. When x is 2, y is 4. When x is 3, y is 9. So I got these points here to plot. Okay, so I got my perpendicular slope, and my point is 2 and 4. So I go through this process, and here is my perpendicular line, my normal line. Okay, so I'm going to plug in that equation in here. I'm going to plug in the x squared here, and then once again I'm going to do second trace for the intersect. I'm going to arrow close to this guy and hit enter, 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 and here we go. Okay, and here's the last one. I hope you found this helpful.